All right, hope you're looking at assignment 11.5. It's a longer assignment than the previous one. It's going to take you a little while to do it. But it shouldn't be that bad because it's mostly at this point review, although I'm asking you to do things a couple different ways. So I want to make sure you understand what I'm talking about. The first little section is hydrogen, lithium, H, Li, magnesium, oxygen, chlorine, and iodine. I haven't got as high as iodine before, so I'm going to go ahead and jump on iodine and talk about how you'd find how many is in outer shell. In this particular assignment, what we're going to do is we're going to go all the way back to the old school. So there's a nucleus in the middle. And the nucleus has, according to this chart right here, 53 protons. 53 protons. 53 electrons, right? Of which, how many can go to the first shell? 2 electrons in the first shell. Boom. In the second shell, well, I'm going from 2 to 10, so there must be 8 in the second shell. Boom. 8. 8. 4, 5, 6, 7, 8. There you go. Next, argon. Argon has 8 more, right? Because 10 to 18, that's 8 more. So I put 8 more in this shell. 1, 2, 3, 4, 5, 6, 7, 8. Love it. Okay, next shell, I'm going from 18 to 36. So that means I get 18 in the next shell. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, I have 36. And I want to get to 53, so I'm only going to add 17 more in the next shell because I'm not going to get to xenon, right? So I'm going 36 to 53. That means I'm going up by 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's 17 in the outer shell, so therefore the answer to I, that's the sixth one of that first set, is to figure out how many electrons are in the outer shell. And I did iodine for you. The answer would be 17. Now I want you to pause this, do the top 5 problems, and then start it back up before you try the next section. All right? Pausing, 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 pausing. Okay, if you've done the first top 5 problems, let's go ahead and go down to the next step. Next step also is iodine. If you look down the left-hand side, iodine is the 1, 2, 3, 4, 5, 6, 7th one down the left-hand side. But I didn't give you a big old space to write a whole bunch of shells and electrons and all that stuff. So how am I going to do it? The answer to the question is we now have a trick, don't we? The trick is we are going to literally say we know krypton has a full shell, right? Which means all I have to do is figure out how many electrons I have after that. So I would go, let's see, I've got a pen. My pen is right here. Okay, so rubidium, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Nothing else matters below it, right? We're just asking about the outer shell, right? So 17, just by counting from krypton on up. Make sense? All right, so the answer to that would be 17. So 2 above that's rubidium. All right, rubidium. RB, rubidium, rubidium, rubidium. All right, rubidium. Rubidium is right here. How many electrons would it have in its outer shell? Well, 1. It's 1 past krypton over here, right? It's 1 more. So 1. What about between them is lawrencium. Where's lawrencium? Uh-oh, I got a bad feeling about lawrencium. Probably shouldn't open up the can of worm that is lawrencium. Lawrencium, there's lawrencium. Okay, so here's what we're going to do. See lawrencium? We're not going to do lawrencium. Cross it out. In fact, any of these ones down here, we're not going to bother with. We're going to give you the discount on these. Anything down here, not my problem. Cross it out, big guy. We're not going to do any of those, okay? So I'm going to look up there. Let's do silver. Silver's hard to find, but it's right Let's have my pen, find my pen, silver. Silver's right here. Okay. So how many electrons is outer shell? Starting over here, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 in silver. Call it a day. Nothing else you have to do except count from the left to the right once you find the element. Okay? All right. Go ahead and pause this. Pause the video. Go ahead and do the next, do the rest of the sheet. It should be fairly easy to do the rest of the sheet. Again, you're just counting from left to right. And when you get done, then start this back up, and I'll talk about how to do the first set of problems on the back. All right. All right, first set of problems in the back. Here they come. It says here, helium, neon, argon, krypton, xenon, and radon are all called noble gases. This set right here. That set right there. That set right there wants to do what? It's got a full outer shell. These are the ones everybody wants to be like, right? So what does it want to do? Nothing. It's already there. Make sense? So how many electrons would it like to lose? 0 electrons. 2, lithium, sodium, potassium, this group right over here, the exploding group. Remember the exploding group from the videos right here? This is them right here. Everything on this list wants to do something bad. Why? Because it wants to become like this row over here. So lithium needs to do what? To become helium, it needs to lose 1 electron. Sodium over here, okay, has 11 electrons. It wants to become like neon and have 10. How many electrons that means it needs to lose? 1. So this whole group, this whole family as we call them, this whole family wants to lose 1 electron. Boom. Okay, you should be able to do 3, 4, and 5. Pause this video. When you're done pausing, we'll talk about how to do the very last set of problems. Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. Okay, you should be done with problems 3, 4, and 5. Let's talk now about the full everything. I'm going to skip down to potassium. Potassium's K, right? Makes no sense at all. I do apologize. Probably means a Latin word for it is, starts with a K, but we don't know that for certain. So here we go. Let me see if I find that. All right, here's my pen. Okay, potassium. So potassium, what does it want to do? It wants to get rid of 1 electron. So we're going to say potassium donates how many electrons? Well, it's got 19. It wants to become 18. So it's going to donate one electron. And when it's done donating 1 electron, it's gotten rid of 1 negative charge. So it's going to become +1. All right? All right. Now I'm going to skip down a couple. I want to do selenium. Actually, you know what? I'll do the one in between too. Strontium. Strontium. So that's potassium. Strontium. Strontium's right here. It wants to get down to 36 decrypton. So it's going to donate 2 electrons. And when it's done donating 2 electrons, it's going to be +2. Selenium. Selenium is over here instead. Selenium needs to get to 36 by gaining 2. So we call that receiving. And it's going to receive, oh, it should just receive, my apologies. Receive, how many electrons does it need? It starts at 34, wants to get to 36, so it receives 2 electrons. Receiving 2 negative charges means it's -2 when it's done. All right, that's how you do the last set. If you have any questions, anyone's throw you, whatever, send me a note, reply to this post, and I will happily send you a reply, and I'll try to explain as best I can. But we're pretty much rounding up this idea, so I'm hoping by now some of this, I'm hoping some of you are taking shortcuts, right? I taught you some shortcuts, right? I taught you that this first column over here all wants to donate 1, and when it's done donating 1, it has a +1 charge. This one wants to donate 2. This group here was a donate 3, donate 4, or receive 4, receive 3, receive 2, receive 1. Too lazy to do anything. We call them nobles. Okay, so lots of different things you can remember, lots of different shortcuts. But that said, you need just one good way to do this to do decent chemistry. So here you are, and I will leave you at this time. Okay, get the assignment done. Turn it in.